Indigenous crafts is any form of art that is made by indigenous community using available raw materials. But did you know that mathematics also exists in this work of arts? Yes, one of the examples are the Batik Fabrics, which are the fabrics printed by Indonesian method of hand printing textile by coating with wax the parts not to be dyed. I'm Makaila Bolos.
I am Paris Bocado.
I am Nisi Katakutan.
And we are the group to present the thesis entitled Application of Mathematical Concepts in Batik Fabrics from Indonesia. One of the interesting works of art wherein one can find mathematics is the Batik fabric. The techniques, symbolisms, and cultures surrounding hand-dyed cotton and silk garments known as Indonesian batik permeate the lives of Indonesians from beginning to end.
This video presentation aims to answer the following. First, in which design of batik fabric are the following types of symmetry applied? A. Reflection symmetry, B. Rotational symmetry, and C. Translational symmetry. Second, in which design of batik fabric are the following types of geometric shape applied? A. Polygon, and B. Curved shapes. Last, what are tessellation found in the study? Where we use 4 different examples of batik fabric bought from Indonesia to answer those following questions.
This study used a qualitative research to gather relevant information about batik fabrics. The study was conducted at College of Arts and Sciences in Pampanga State Agricultural University in Magalang, Pampanga during the school year of 2015 to 2016. And the researcher used the 4 batik fabrics bought from Indonesia as the main instrument to conduct the study.
Here are the procedures used by the researcher in conducting the research. First, the researcher gathered and analyzed relevant data from books and internet. Next, the researcher gathered available batik fabric products, then concentrated on recognizing each mathematical concepts, started with symmetry and to geometric shapes, tessellation, and finally fractals. But there weren't actually any fractals in the 4 batik fabrics used. Lastly, to show which mathematical concepts, the image was cropped. The researcher edited the study after presenting it to the panelists.
Now, let's move on to the result of the study. The first math concept that batik fabric has is the symmetry. In this study, there was 3 out of 4 types of symmetry found: the reflection symmetry, rotational symmetry, and translational symmetry. Under line symmetry, it was classified into 4 types: x-axis, y-axis, y is equal to x, and y is equal to negative x. There were 6 designs in Malong B, 4 designs in Malong C, and 5 designs in Malong D under the x-axis symmetry. Under y-axis symmetry, there were 2 designs in Malong A, 8 designs in Malong B and C, and 4 designs in Malong D. For the y is equal to x and y is equal to negative x symmetry, they have the same finding of designs, where 1 design in Malong B, 3 design in Malong C, and 2 design in Malong D was found.
In rotational symmetry, 5 types of order were used: order 2, order 3, order 4, order 5, and order 8. There was 1 design for Malongs B and C and 2 designs in Malong D that were found to be under order 2. There was 1 design found for each Malongs employing order 3, except for the Malong D. 2 designs in Malong B, 3 designs in Malong C, and 1 design in Malong D were found under order 4. There was also 1 rotational design in order 5 found in Malong A, and for the order 8, there was only 1 design found, and it was from the Malong D. For the last type of symmetry, the translational symmetry, there were 6 designs from Malong A, 4 designs in Malong B and Malong C, and 3 designs from Malong D.
The second mathematical concept that batik fabric has is a geometric shapes. This study employed 2-dimensional or 2D shapes such as polygons and curved shapes. Malong A has a polygon, an equilateral triangle, and curved shapes such as crescent, quinfoil, and heart shapes. In Malong B, there were an acute and obtuse triangles and a rhombus or polygon. There was no curved shape used in this Malong. Meanwhile, for Malong C, there were a square and curved shapes such as lens, ellipse, and quatrefoil. Lastly, for the Malong D, a square or polygon and an annulus and teardrop or curved shapes were used.
For the last mathematical concept that was applied, there were tesselation found in Malong C and Malong D. The types of tesselation found were based on Esser tesselation, which is tesselation with glide reflection in Malong C and tesselation with rotation in Malong D.
These are the recommendations of the panelists about the study. First, other researcher could use other materials that apply symmetry. Second, other researcher could use or study other materials that apply geometric shapes. Third, other researcher could use or study other materials that apply tesselation. Lastly, other researcher could further investigate for other mathematical concepts that can be applied in batik fabrics.
After we analyzed and finished this presentation, we realized that behind all the works and objects whether made by humans or by nature, whether arts or anything else, if we will give attention and be more appreciative on our surroundings, we will able to see how beautiful and valuable mathematics is.
We saw how much it has contributed to things we never thought there is math, especially in art. We discovered different beautiful designs and patterns on the batik fabrics, which we actually don't know that there is math behind it. But only because of this research, we learned something new. The mathematics behind those work of arts, and of course, the malongs or the batik fabrics itself.
It's interesting to observe how the majesty of batik fabrics reveals not only the wonderful culture of Indonesia, but also the real beauty of mathematics. It's indeed, when math and art combine, it will make a beautiful result. I hope this presentation will give you a lot of lesson and will encourage you to study more about math, and also to appreciate arts and crafts of different culture from different places. Again, I am Missy Katakutan.
I am Alice Puhat.
And I am Makayla Bolos, your presenter. Thank you.